Welcome to section 9.5, the distance formula. Today's section we're looking at a formula that can help us find the distance between any 2 points that are in the coordinate plane, as long as we know what the coordinates are. So before we do that, we want to get into why the formula works, where does it come from before we start applying it. So if we have a graphic right here, we have an x-axis and a y-axis. I'm trying to find the distance from point A to point B. Now I can set up a right triangle that will help me solve this. So essentially what I've done here is at point C, I'm looking for how far is it from A to C. If you look at the y-coordinates, they're both the same. They're not any different at all. But the x-coordinates are different. And the way I find out the distance between point A and point C is I take x2 minus x1. I'm going to do a similar method for point B to point C because from B, it's straight down to point C. Our x-coordinates are the same. The y-coordinates are different though. I've got y2 and y1. Let's say it's 8 and 2, I would take 8 minus 2. And that would tell me the distance in a vertical direction from point B to point C. Now, because I've set up a right triangle, if I know the distance here, x2 minus x1, I can square that. And I know the distance here, y2 minus y1, I can square that. If I add them up, that's supposed to equal my hypotenuse squared. Now I'm looking to solve for D, so if I had that equation, x2 minus x1 squared plus y2 minus y1 squared equals D squared, I would take the square root. And what I end up with is the distance formula. D, the distance between 2 points, x1, comma y1, and x2, comma y2, is given by this formula. x2 minus x1 quantity squared plus y2 minus y1 quantity squared, the square root of the whole quantity. Now, in reality, it doesn't matter what order you subtract the coordinates in because we're squaring them. A negative times a negative is a positive, and so is a positive times a positive. So if it's more convenient, sometimes I'll do x1 minus x2, or I might do y1 minus y2. It gives me the same results. So here we want to calculate the distance between the points negative 2, comma 5. So I'm going to label this as x1 and y1. And the other point is negative 6, comma 5. x2, comma y2. To find the distance, I use my distance formula. And I want to subtract in a convenient way. So a way that's not going to give me any problems. So I'm going to take negative 2. Try that again. There we go. Negative 2 minus negative 6, so plus 6 squared. And I did that so that I can avoid negatives wherever possible. Plus 5 minus 5 quantity squared. So when I put these together, negative 6 plus 2, that's going to give me 4. Five minus 5 is 0. That squared is going to be 0. So this would be the square root of 16, which is 4. Now you might have noticed that we didn't actually need to use the distance formula in this one. Both of your y-coordinates are exactly the same. So the only difference between the coordinates is how far apart the x values are. From negative 6 to negative 2, it's positive 4 away. An important point to note is that with distance formula, we are measuring something. So we are only going to have positive answers for our solutions. We're not going to take the square root of a negative number. That's something that we're not able to do just yet. And example 2 is calculate the distance between the points negative 8, comma negative 6 and 7, comma 2. So again, same type of process. I want to make sure that I label my points. And I'm labeling that so that we remember the difference between an x-coordinate and a y-coordinate. If you're really familiar with that, you don't necessarily need to label them. In this case, I'm going to take my second x-coordinate minus my first. A positive minus a negative would be a plus, so 7 plus 8 squared plus, and in this case, negative 2 or positive 2 minus a negative 6 is a plus 6 squared. So what I end up getting with 7 and 8 together is 15. 2 and 6, I get 8. And when I add these guys up, 15 squared is going to give me 225. And 8 squared is going to give me 64. Putting it all together, I get the square root of 289. which turns out is 17. That's a perfect square. If your radical isn't a perfect square, then you need to simplify it. If I had something like the square root of 24, I would have to simplify it down to 4 and 6, giving me 2 root 6. Do not give decimal answers. We want the exact answers. We want the simplified radicals. Now, the interesting part about this here is that 8, 15, and 17 are all whole numbers. So that's another one of those Pythagorean triples that we're going to work on next. We've been alluding to it all the way through. Very important that you start becoming familiar with those. And that is it for the notes today.